Hello everyone, this is Giuseppe Maggiore and welcome to the lecture on conditionals of the course Introduction to C#. Why conditionals? Well, conditionals are perhaps one of the most basic yet fundamental construct in virtually all programming languages for the last, 60, 70 years, and perhaps actually even more, because before we even had programming languages, like in the lambda calculus, a theoretical model of programming, before programming even existed in the 30s, in the year 30s of the last century, conditionals were already one of the constructs that were available. And why are conditionals so important? Because the ability to say, okay, take stock of the situation, and if you observe or measure something around you, then do this, otherwise do that. This ability to choose your course of action, or at least in our case, your course of virtual action, is the foundation of the encoding of intelligence. Now, conditionals come in two flavors: expressions and statements. Now, statements are things that do something, like this. Line 1 is a statement. Why? Because it does something. It just prints something on the screen, so it changes the memory of the program. It imprints some pixels, but that's a statement. But also, this x is equal to 1, var x is equal to 1 declares a new variable, so it changes the state, adds a new variable to the state, and as such this is a statement. X is equal to x plus 2, this is also a statement, because it changes memory. But just x plus 2, this is an expression. So the difference between a statement and an expression is that a statement actually changes the state of memory. It declares this is happening now. An expression, on the other hand, it's a more neutral thing. Like if you say var b, which is boolean, is whether or not x is different from 0. X is different from 0 is an expression. On its own, x different from 0 doesn't change memory. Console.write line of x plus 1. Now, the write line itself is a statement, but x plus 1, again, is just an expression. Conditionals come in two flavors: expressions, conditional expressions, and conditional statements. But in general, conditionals are based on the same three ingredients. Let's look at the ingredients first. We have the condition itself. The condition is a Boolean expression, so it's an expression that evaluates to either true or false. X is not 0. X is greater than 0. X is smaller or equal than 0. X is greater than y, but also x is equal to 0, and y is not equal to 0. So all of these, separated by comma, are different examples of Boolean expressions that can be the condition. Then we have the then branch, which is either an expression of arbitrary type or a series of statements to evaluate or execute or run when the condition is true. And then we have the else branch, and the else branch is basically the same, so an expression of arbitrary type or a series of statements to evaluate or run when the condition is false. And the else branch happens to be optional, even though I have a very outspoken opinion about the fact that this optionality of the else branch is very rarely a good option. Okay, so conditional expressions will always follow this template: condition, question mark, then, else. Where then and else are expressions, they may have whatever type you want, as long as the then expression and the else expression have the same type or two types that can convert implicitly to the same type. But this we'll cover later. For example, let's say we have the age. Now, this sort of thing works best if we deal with conditions for which we can't say beforehand whether or not they will evaluate to true or false. This is actually where conditions and conditionals become interesting. So let's say we have an age that we read from the console. So we ask, please input your age Then we read the age by, well, let's be pedantic. System.int32.parse, and then parse console.readline. Minor sidetrack, we get a warning here, because readline might return a null string. And how do we know? We know because the type of console readline is string question mark. Okay, so let's say that if by some reason console.readline, because there is no input anymore, is null, then we want to use the null coalescing operator, double question mark, which says, okay, if the thing on the left is null, use this as a fallback. Actually, we could do this with a conditional expression. We could say, okay, let's read the input. Let's console read the line. Then if the input is equal to null, use the string 0. Otherwise, use the input itself. This comparison with null, where we say compare something with null. If it's null, use the fallback, otherwise use the variable itself, is so common that the shorthand is this. Saves us from having to declare a variable. So the null coalescing operator is the simplest conditional expression where the check is on the left side and it's an implicit check for nullness. Okay, now let's say that we want to print whether or not the person in question may vote. So if the age is greater or equal than 18, then you may vote. Otherwise, you may not yet vote. Let's run this little program. Please input your age, 38. I may vote, but let's look back. Say I'm still 12. No, I may not yet vote. Okay, very good. Look at what happens if I try to put things of different types. Let's actually put this in a variable. Okay, now, well, there's an error. We actually get an error. It says, okay, the type of the conditional expression cannot be determined because there is no implicit conversion between string and int. I am wondering, though, why this is being accepted, even though I do have an idea. Okay, yes, write line in this case, it's also capable of accepting an object. Object is the type that everything can be converted to. So this is actually quite dangerous in this case. An object is sort of a wildcard for types. So string is also an object. 10, so int is also an object, so this cast is allowed, but you may not put this in a variable, because if you put it in a variable, then C# is not going to accept automatically that this variable might be of type object. So being of type object is something that requires an explicit declaration, not var, because otherwise var would always, in case there is a big mismatch between types, var would simply force everything to fall back to object, and this might actually be too much. So also interesting to see that this in general is not really allowed unless you pass it to a function that accepts object. In that case it gets allowed, even though it isn't really. Now, this conditional expression has the two branches, the then and else branch, because we're checking on a boolean. In recent times, C# actually introduced the so-called switch expression, which allows us to perform more checks. I find this actually quite exciting. So this allows us to check not against just a boolean, but against the different shapes. I can say age switch, then curly brackets, and here I can actually put a series of so-called shapes or patterns. So for example, I could say, okay, that, well, this is quite ugly. Let's say I just want to convert the age to a string. So this is 0. You can see pattern thick arrow that's equal and greater than, and then whatever we want to return. So this it's like having multiple branches, like then 1, then 2, then 3, etc. 1 is 1, 2 is 2, and then for anything else, underscore, so the wildcard, I don't, okay, yeah, more than 2. Obviously, this is not really, well, you wouldn't attempt to turn numbers into strings like this, but it's just to show that you can match over multiple patterns. Let's run this program, the age, so if we put 2, well, we get 2, but if we put 4, we just get more than 2. Let me restart my terminal because, yeah, okay, now I can see, what I'm typing. I don't know why, but it was sort of gone. So also this syntax for switch, well, it can match whatever we want. So what we have here might also be a more complex variable, a record, etc. We will see it later. And this is the switch expression, which is in a sense, well, it can also encompass conditional expressions. So it's more because it can match on any patterns. But for example, if we say age greater or equal than 18, well, obviously this doesn't work now because the patterns are not Boolean. So here we have true. We can say you may vote, and if the pattern is false, then you may not yet vote. I see that there's some misunderstanding about, oh, okay, yes, very interesting. Switch has higher priority than greater equal, so let's put it between brackets, because otherwise the switch was matching on the 18. So this was age greater than equal, and then the string coming out of this, but if I want to actually check the whole Boolean, I have to put it between brackets. Okay, no issue. I actually really like this, even for Boolean conditionals. I mean, I understand that you could simply say, okay, question mark, and then here you may vote, and otherwise the colon, but I really, really like the cleanliness of this syntax. I don't know why. I'm a bit of a sucker for things like arrows, for example, so yeah, sue me. Conditionals also come in the more powerful form of statements. A conditional statement will always follow this usually multi-line template. We have the if keyword, then we have the condition, then, well, we have the then block or the then branch, else, and another keyword, and then the else branch. Now, the then and the else branches are not expressions in the if statement. They are statements themselves. They can be just one statement or multiple statements, and then in this case, if it's multiple statements, we will have curly brackets, and then all the statements of the then branch, one after each other. So then branch 1, then branch 2, etc. until then branch n, whatever that may be. And the same applies to the else branch. Okay. We can simply say that we have a single statement as the then branch, but statements may also be composite. So the semicolon operator is the operator that stitches two statements together in just one bigger statement. And well, it's just perhaps a sort of a theoretical description this, but the effect is the same. Now, this is a flow control statement because first we evaluate the condition. If the condition is true, then we jump inside the then branch, and when we reach the end of the then branch, we jump over the else branch. If the condition evaluates to false, we skip the then branch and we proceed with running the else branch. in the case of this voting status, which, by the way, let's give this a better name, voting status. Okay, we could roughly achieve the same, but we would have to say the voting status starts as empty if the age is greater or equal than 18. Let's go for the then branch. I'm trying to preserve the original bits to show how they, from the previous conditional, to show how things morph. Else, and then the voting status gets assigned to you may not yet vote. Okay, very good. Now, when you're just assigning a single variable in both branches, then there is no reason whatsoever to use a conditional statement rather than the previous conditional expression. Better yet, the conditional expression didn't require us to put a placeholder value in the voting status variable before it's initialized, so it's actually cleaner, it's shorter, it fits one line, etc. But conditional statements do have a few tricks up their sleeves. Namely, it is possible within these statement blocks to actually declare variables and perform whatever we might want. So, we could define a variable, let's call it temp. Yeah, okay, now this is very pointless. We will see better examples of if then else in the exercises. But so look, we can declare a variable temp and reassign this variable. And one of the things that are interesting about these little variables in the then or else block is that at the end of the if, they are cleaned up. And this is the power of scope. The then and the end statements, the then and the end blocks, are a full-blown scope where we can declare new variables or where we can even perform other conditionals, loops, declare all sorts of things that are only limited to the block itself. So as soon as we reach this curly bracket on line 20 or this curly bracket on line 22, whatever the then branch or the else branch had allocated or declared better, I should say, as soon as we reach the closed curly brackets, those things are all cleaned up. So we can define a temporary, local context of the then or else computation. And even better, the then and the else computation may differ from each other. So let's say that, let's say that we have these two variables, temp in the context of the if and temp in the context of the else are not the same variable. Better yet, we would even give them different names. So temp then, temp else, and you can see that they have a separate scope, that they are separate scopes. And obviously temp then is not available here. So if I try to access temp then I get an error that clearly states temp then does not exist in the current context. Same applies to temp else. And neither of them, temp else, for example, does not exist in the current context. Temp then does not exist in the current context. You might argue that, well, if both variables are called temp, then at the end of the whole if, the temp variable might be there. Why? Well, because both the then statement and the else statement declared the temp variable. But the point of this mechanism is to have a local context that does not leak outside of the whole if then else. So even if we have the same variable, the variable will still not be available outside the if then else. And also you can imagine that if we have the same variable with the same name, the types might differ. So we could have a variable x of type int here, and the variable x of type boolean, and also that's not an issue because the computation of the then and the else branch, well, it might be a completely different computation with different variables, etc. Now, just like the conditional expressions have two flavors, one for booleans and one for things that are more than booleans, so that have more cases than booleans. Also for conditional statements, we have a statement that deals with booleans, the if statement, but we also have statements that deal with multi-shaped values. And this is the switch statement. Now, we have again the switch keyword, but in this case, for the switch statement, the thing we switch on is to the right of the switch keyword and not to the left. Then we have a series of cases where we put the shapes we want to test the argument, the parameter that we pass to the switch, which can be an arbitrary expression. We have the shapes we want to test against. If the test passes, so age and 0 match, then we can write a series of statements. Also here, just like the if statement, we are free to declare variables, we are free to do whatever we want. And now we can print 0, then break, then in the interest of time I will do 0 and 1. Now let's do all three of them. 2, and finally, if none of the cases are matched, we have the default case, and in this case we write more than 2, and again break. Why do we have break? Well, we can comment break out, but we actually get a compiler error. This is a very old behavior of cases that break basically says, okay, when you reach the break keyword, jump at the end of the switch. Otherwise, the first condition, the first pattern that matches, we start executing the code and then we would just enter automatically all the next cases. So this was built in order to be able to say something like this, multiple cases on top of each other, and then you fall into any of the patterns, and then you start executing the code basically that's under all of them. But, well, this behavior where you can remove the break, and then if you enter in case 0, you run line 18, and then you start entering 20 and 22, this behavior was possible in C and C++. I think this might have only caused bugs in the history of programming, and at some point this was made a compiler error. But yeah, just so you know why you have to specify break explicitly, even though it's kind of required. Conditionals may be nested. So there is no limitation to how much we can nest conditionals. For example, let's go back to conditional expressions. This is something I use so often. Let's say that we have the age and the nationality. And for the nationality, we also read line, and, well, I will use the Italian nationality as a placeholder, as a wink to my birthplace. Okay, so, and also let's say that we want to know whether or not the person in question lives abroad. And this will be system.boolean.parse. And okay, so the voting status now will be a more complicated series of checks. So let's start by, is the age smaller than 18? Well, in this case, Then in this case, the person in question, may not vote yet. Then, and now we may put another conditional. Let's say that, if the person lives abroad, then may not vote for the local elections. And otherwise, yeah, okay, two conditionals are enough. I have a bigger example, but this is enough. So two conditionals are enough, and then in the second else branch, basically, I get to say may vote. There you go. So, the two conditionals are the whole thing. The whole thing. This is the first conditional, and this is the second conditional. But the precedence of operators is such that the second question mark ranks higher than this colon, and well, the way these things are associated is to the right, so that this conditional and its nesting do not require any explicit brackets. So we don't need to do this. We don't need to put these brackets. And you may you may put all sorts of checks. So here you could say, okay, now other check. So when age greater than 32, and then you have something here, and then age greater than 64. Yeah. Okay, now this makes no sense. Smaller than 32, smaller than 64, and so on. So you can have this cascade of. You may have this cascade of question mark colon question mark colon question mark colon as far as you want, actually. So you could have plenty of patterns here, and yeah. At some point, if you have too many patterns, then the switch statement might actually be slightly better, but that's up to you. It's actually quite common to have multiple patterns and to need to discriminate between all of them. And this is a form of nested conditional expressions. We can achieve the same with conditional statements, of course. So, for example, we could say, well, I'm going to rewrite this very same expression. If the age is smaller than 18, then the voting status is may not vote yet. Else, if lives abroad, then the voting status is may not vote for the local elections, and else the voting status is finally that the person may vote. A very good property of if statements, even when nested, is that we can put, for example, breakpoints. So this is the breakpoints don't work as well for big and complicated conditional expressions, and here you can also put console.writeLine for testing. So you could, it's easier to put logging statements, like you could say console.writeLine, and then here you put a warning because you want to, there's a bug when the voting status is may not vote for the local elections, and so here you might decide to print all sorts of things like age, nationality, and lives abroad. So that's also interesting. One of the practical differences between statements and expressions is that while expressions are shorter, cleaner, and also semantically better, because this I find really ugly. And until voting status is assigned, it has a bogus value. That's dangerous. It's just one of those little corners where bugs and issues might be hiding, might be lurking. But with conditional statements, we have more flexibility. We can put debugging statements, the breakpoints work a bit more reliably, etc. So once again, it's about about the scenario that you're dealing with. All right. So I would say, well, no, before I say that this concludes our lecture, well, there is also the possibility, and this you might see quite often in practice, to put all of the conditions and all of the conditionals in a cascading sort of selections that are one after each other by having else if right next to each other. So yeah, remember when I said you don't always need the curly brackets, so this would be one of the cases. So the else branch of the first if in this case is a statement, but the whole if is just a statement, and so you can just put the if as a statement right after the else, and then the curly brackets of the second if ensure the correct grouping. And you can have if else, if else, if else, if else for as long as you want. So here you can also have another if and another else and another if and so on. And yeah, you can go on until well, again, you can go on to your heart's content. I find it exceedingly important to have an else branch, even if statements do not allow an else branch. Why? Because you always need both legs for walking. This is how I would advise you to remember it. It is never an option to ignore how to handle explicitly the result of a conditional that doesn't match. And very, very often, at least in my professional career of, at this point, quite a lot of years, when an else is missing, it usually means that someone is not thinking about the unhappy path. And this is almost always a source of bugs and issues and broken things. Usually, if you have an if that checks, okay, are all conditions met in order to perform my computation? That's great, but the else means, okay, so the conditions are not met. And you may never assume that the conditions will not be met. If you have dynamic conditions in your program, like variables that are never supposed to be one smaller than the other, and you check that they are, you also have to do something when they aren't. And well, yeah, if it's just giving back an explicit error or asking the user to revalidate the input, it doesn't matter, but we must manage the unhappy parts of our application. And this means complete those else's. And with this, thank you very much for listening. I hope you've enjoyed this lecture. See you soon for the next lecture on loops. And until next time, bye bye.